All right, so one of the special things about an isosceles triangle is I can always draw this special line right down through the middle of this thing, okay? It goes from the vertex angle, which is the angle that's kind of at the top here. It's the angle that's not the same as the other two, all right? And it will, when we draw this special line, it will bisect that angle, all right? It will be perpendicular to the opposite side, and it will also bisect the opposite side. All right. And it has all those special properties. And really, the thing that's really cool about this is if it has any one of those properties, it automatically is that special line and will have all the other properties. In other words, if I were to draw a line that's perpendicular and bisects the bottom side of this thing, then it's automatically going to bisect the opposite angle as well, all right? If I draw it so that it bisects that angle at the top, it's automatically going to be perpendicular to the opposite side and cut that opposite side in half, all right? And so there's this special line that can be drawn. Now, here's the thing, like I can draw all kinds of lines in this thing and they won't necessarily be that special line. So here's this triangle. I could draw a line that goes like this, all right? And it wouldn't be that special line because notice it doesn't cut this angle in half, all right? And if I make it so it cuts that angle in half, it'll automatically be this special line. Notice it also doesn't bisect this guy, all right? So it's just a special line that can be drawn. And as soon as I see one of these features, I know that I have all of these features. In other words, if I were to draw a triangle and say, hey, this is an isosceles triangle, if I drew some line like this, we don't know if that's the special line, but as soon as I do this, as soon as I say, hey, this is perpendicular, now I know that it is that special line. If it has one of the properties, like being perpendicular to the opposite side, it automatically has the other one, which means now I know that this guy is equal to this guy. I know that it bisects that thing. I know that this angle is equal to this angle, all right? As soon as I have one of those features, I know it's that special line and I have all of the features, okay? For example, if I look at something like this guy, it says find X, Y, and Z. And so really all I need to decide is this that special line? And remember, we label things in terms of being congruent with the same number of dashes or arcs. So right here, notice I have a purple arc here and a purple arc here. I'm showing you that those two angles are the same. And so if those two angles are the same, it means that that angle up there is being bisected. That automatically tells me, because that's one of the three features, bisecting that angle, bisecting the opposite side, and perpendicular to the opposite side. And if it has one of those features, it automatically has the other features. And so for this one, because it bisects that angle, I automatically know that this is now going to be perpendicular. I automatically know that these pieces are going to be congruent. All right, it's going to split that opposite side in half. And so as I look at this thing, right away I can tell that y is going to be 5 because that whole side is 10. Y has to be 5 because this line automatically cuts that thing in half, okay? I also know that z, that angle, is 90 degrees. So right away I have a lot of things that I can find here. So let's see, I've got x, I've got y, and I've got z. Right now I know that z is 90 degrees. I know that y is 5. But then the other thing I know, because I can go back to that idea that, hey, when I look at this thing, if this side is the same as this side, all right, then that means this angle is the same as this angle. So let me label that bottom angle. Remember, in an isosceles triangle, we always have two angles that are the same. It's 54 degrees. And now think about this smaller triangle. Think about this triangle that I've created right here. I'll outline it in purple. The three angles inside that small triangle add up to 180 degrees. And I already know that z is 90 degrees. So now I can say, hey, you know what? The 90 and the 54, that's a 144. And if I do 180 minus that, that gives me a 36 degrees. So that's got to be angle x, okay? So again, we're just trying to pull all of that knowledge that we have together, and we're just going to continually add to that, all right? If I look at the next one, same kind of thing. I look around this thing, right away, you probably realize that, well, the base angles, these guys down here, this 63 degrees has to be the same as this guy, 63 degrees, because it's labeled as an isosceles triangle. Also, side Z, right here, that has to be 13 meters because, again, right here, that's what these little dashes means. It means those are the same. So this is labeled as an isosceles triangle. And then from there, I could find y. I know that because this is a right angle right down here, so because I see that this is perpendicular, it means it's that special line, which means that this angle up here is being bisected, all right? It also means that this guy right here is being bisected, so this bottom piece is split into two equal pieces. So if the whole thing is 7, y, let me do x, y, and z, y has to be half of that. It's got to be a 3.5, okay? Because remember, 3.5 and 3.5, that's what's going to give me the 7. So I got to divide that by 2. Z already has 13. And now for x, there's two ways that I can find x here. I can look at the whole triangle and say, hey, these guys together, is 126 degrees. And then I could find this whole angle and then divide it by 2. Or I could look at the individual triangles again. I could look at these little triangles and say, hey, let's look at this little triangle. The three angles inside here have to add up to 180 degrees. Right now I have a total of 153 when I add the two angles that are in there together. So now 180 minus the 153 looks like a 27 degrees. So that's got to be x. Okay? But again, it's this special line that if it does any one of these three things, it does all three things. It bisects that top angle, it's perpendicular to the opposite side, and it cuts that opposite side into two equal pieces.